All right. So we're going to do a couple of examples together and then some problems. And again, I really want to talk about what makes an answer reasonable. So let's take a look at example 1 together. Example 1 says Elsa won 40 lollipops playing basketball at the school fair. She gave 2 to every student in her math class. She has at least 7 lollipops left. So a really good word problem strategy that I've seen some of y'all do is you go through and you circle or underline the important information, yes? So what should I circle or underline here? 40 lollipops. Would you circle that or underline it? Underline it? Okay, so I've got 40 lollipops. It says she gave 2 to every student in her math class. What should I underline there? 2 to every student. And at least, I'm going to circle that one because that's an important word, right? At least 7 lollipops left. All right. Is going to be less than or equal to beautiful because it's that at least, right? Very nice. Oh, I didn't cut all the way on the dotted line, so my window won't open. Fixed it. All right. So then I've got 2 questions inside. So on the left side it says write an inequality to represent the situation. And be sure that we define the variable. So did I give a letter for our variable? Did I already define our variable? Did I say what our variable had to be? No. So it can be anything, but I want to know also what does that variable mean. Okay? So first let's write our inequality. So I've got, so Elsa gave 2 lollipops to every student. Do we know how many students are in her class? No. So if I say 2, so 2x would be what? How many lollipops she gave away, right? All right, so I've got 2x. I have 7. And we started with 40. Oh, I need a new marker. It's way too light. Hold on just a second. Here we go. I have 2x, I have 7, and I have 40. Better? Good, good, good. Okay, so how am I going to put those together to write a math sentence that matches Elsa's situation? Well, she's giving 2 away, right? So is she adding or subtracting her lollipops? Subtracting. And what is she subtracting from? From the 40. So I can say 40 minus 2x. And then it says she has at least 7 left. Equal 7? Well, it's going to be or equal to, right? Because she could have 7 left. But which way is my inequality going to go? What's going to be greater? How many she has left or 7?
How many she has left?
Because it says she has at least 7 left, right? So could she have more than 7? Yes. All right. All right, so I'm going to say x, and I'm going to define my variable down here. What is x? The number of students. All right, so B says solve the inequality to find the maximum number of students in her class. And that's helpful because it says maximum. So it says we can't have more than how many students, right? All right, so let's set this up. I've got 40 minus 2x is greater than or equal to 7. So to solve here, what do I need to do? Subtract which one? 40 because I've got, we want to think outside of the box first, right? So if I subtract 40, then I have negative 2x is greater than or equal to negative 33. Okay, good. All right, and then what do? We got to think inside the box now. Divide by negative 2. Beautiful. So now I've got x. And what happens to my inequality? It's going to flip. So x is less than or equal to positive Is it 16.5? 2 goes into 3 once with 1 left over. 2 goes into 13. 16.5, right? Okay, sorry. You're exactly right. I was thinking of another number. All right. So x is less than or equal to 16.5. So let's talk about the reasonableness of this answer. So what does this mean? So x is my number of students, right? So the number of students is less than or equal to 16.5. Can we have 16.5 students? We can have 17, right? So should I round up to 17 or go down to 16? Down because we can't have that half of a student, right? So that would be like adding another student. So this would be one of those cases where we have a 0.5. Normally we would round that up because 5 or bigger we round up, right? But if we're talking about pieces of a student, we can't talk about pieces of a student. You can't have half of a student. So we're going to go ahead and truncate. We're going to round down to 16. So I'm going to write x is less than or equal to 16. We don't have that other kid yet, exactly, because they're thinking of just part of a kid where we're almost going to be there, right? Very good. All right, so I could have 15 students, right? We could have 10 students. Yes? Could we have 2 students? What about 0 students? Ooh, I saw a few head shakes. No. There's not going to be a class, right? And we know there's at least 1 student in the class, right? Elisa? Right? So could I write something on the other side to give me an at least, to give me like a range of students? So x has to be greater than what? X has to be greater than what? 0. We have to have at least 1. We know we have at least 1 student, right? Elisa? Right? So I'm going to say, so 0 is less than the number of students, is less than or equal to 16. So what this means is the number of students is between 0 and 16. Exactly. And the arrow points to 0 because that's the smaller one. Is that okay? A little bit. Let's try another one. Question. Example 2 says Bill spent less than $26. Spent less than, right? $26 on a magazine and 5 composition books. And then I know that the magazine costs $4. So here it says a magazine and 5 composition books. What's the math word for and? Plus. You see what I'm saying now? That's all that looked like. What are you talking about? A math word. So we've got plus, minus, equals, multiply. Those are the math words I mean. All right, so here I could say a magazine, right? Can I abbreviate magazine? And 5 composition books. But what do I know about that magazine? How much does the magazine cost? $4. So I can substitute $4 for my magazine, right? So let's go ahead. It says write an inequality. So I've got 4 plus 4 plus, well, I have 5 composition books. Plus 5. Plus 5 what? Like 5x, right? Because 5 times x, I know you did. But you stopped like, I don't know what I'm doing. Wait, you started to like back up. No. Keep going. You had it. So 5x, because x is what? What does x mean here? Is it the number of composition books or is it the price of a composition book? The price. X is the price of a composition book. Can I abbreviate composition book? Is that okay? Can I say comp book? All right, so and it's less than 26? Because what Bill actually spent is less than $26, right? Beautiful. Bless you. So let's solve it. So to solve the inequality to find the maximum cost of each book. So I have 4 plus 5x is less than 26. So what's my first step? If I want to isolate x, we want to get subtract 4. Perfect. Now I've got 5x is less than 22, you say? Mm-hmm. And then? Because we divide both sides by 5. So you got x is less than 4.4. Now we're talking about price here, so I'm going to go ahead and put in my units. All right. So again, I want us to think about the reasonableness of the solution. Does it make sense that a composition notebook would cost less than $4.40? Does that make sense? Yeah? All right. So if we keep going down, because that means x is to the left, right? It's everything below $4.40. Where would I stop? At 4? At 0, because can a composition notebook cost less than $0? No. It could, okay, so it could be or equal to 0, right? Because maybe it's free, but are they going to pay us to take it? Is it going to be negative? Probably not, right? So I'm going to add in here greater than or equal to $0. I'll go ahead, we could have 0 in there, right? It would make sense for a composition notebook to cost 0, right? Maybe you've got a coupon. Maybe they have some kind of special deal. Maybe. Because if I plug in 0 here, that's 4 is less than 26. Does that make sense? Is 4 less than 26? Yes. So that's a true statement. Is that okay? A little bit? All right, let's try one more together, and then you guys are going to try a few on your own. You ready? Example 3 says, Amanda rented a bike from Shauna's Bikes. They charged her $2 per hour, plus, one of those math words, plus a $10 fee. Amanda paid less than $27. So let's write an inequality and define our variable. So I want to know, what does my variable mean? So what should my inequality say? 2x, because what does x mean? Hours? What kind of hours? Like how many hours, or the length of an hour, or per hour? So if it's per hour, we're counting what about the hours? Each hour, the number of hours, right? So the number of hours. All right, so I've got 2x plus, because they told us already that it was plus, right? Plus what? 10. So what that means is Amanda's going to pay $10 and then $2 for every hour. So if she's on the bike for 1 hour, it would be $12. If she's on the bike for 2 hours, it would be $14. Right? All right, and then I have that Amanda paid less than $27. So what inequality symbol do we need? Which one? The top one or the bottom one? The bottom one? That one's greater than. Top one is less than. All right, let me write it in and see what happens. I've got less than 27. Uh-oh. Turn your phone off, please.
What? Oh, that's you. I was like,
Turn it off, please. All right, so less than. So what Shauna actually paid is less than 27. All right. So we're going to solve the inequality to find the maximum number of hours Amanda rented the bike, that she could have rented the bike for. All right, so I have 2x plus 10 is less than 27. So what do I do first to solve for x? Subtract 10. So I'm going to have 2x is less than what? 17. And then divide by 2. Y'all got it. So x is less than is that 2 goes into 17 8.5 times? Beautiful. So x is less than 8.5, but it's got to be greater than what? It's got to be greater than 0, right? Could it be equal to 0 hours? I see some yeses and some nos. Why not? Well, can it be less? Could she have the bike for a negative amount of time? No, so we know that reasonably it has to start at 0 or be greater, right? But could it be equal to 0? Could she rent the bike and then not write it and just turn it right back in? Yeah, right? Well, then if we put that 0 in, is 10 less than 27? Yes. So it still works, right? Is that okay? So she rented the bike, drove it for 0 hours. All right. So I'm going to make this her equal to.
she still wouldn't have to pay though, right?
Well, it depends. If it per hour, right? I'm so glad you brought that up. So I have 8.5. And to answer your question, can I ask another question? Okay. So I've got 8.5. So can I have half of an hour?
Yeah.
We have to have fractions of an hour, right? So they may charge by the hour, right? So it starts every hour, but she can have it for part of an hour. Does that make sense? All right. So I want you to work in your groups on problem 1, 2, and 3. I'm going to give you guys about, what do I got? About 12 minutes, and then we're going to review these 3 problems together. So for each problem, I want you to write an inequality and solve it. Sorry, you couldn't see. Write an inequality and solve it. Be sure you tell me what your variable means, and make sure that your answer is reasonable. Okay?